So today we are going to start chapter 5. I know we just finished up chapter 4, which was really long. Chapter 5 is similar to chapter 4 in, I guess you could say, the length, but there's also going to be some memorization that needs to happen because now we're going to get into the muscular system. As you can see, we have two amazing models right here, Patrick Star and of course Thor, or Chris Hemsworth. But to start off with the muscular system, we need to talk about what exactly is a muscle tissue? What are they made up of? What are their functions? So muscle tissue, or muscle itself, can be broken down into three categories. We have skeletal muscle, smooth muscle, and cardiac muscle. If you're looking for this in your notes, just hold on a second. This is just kind of give you an overview. Each of these muscles, sometimes they overlap in how they look. Sometimes they don't. They look completely different, which can be a good thing because it helps us distinguish which muscle belongs where and what their functions are. So the first muscle that we're going to look at is your skeletal muscle. And just as a background, muscles are so important for our body, right? They are used whether it's you're blinking, you're texting, you're playing a sport, you're being super active. These are all some really crucial, important things for your muscle. And one of the main muscles that we need to talk about is your skeletal muscle. This is literally the muscle that's attached to your bone, right? This is what allows you to move. This, if you look at the way that it looks, it has a striated kind of look, which basically means it just has lines going through it. Another name for skeletal muscle is actually called striated muscle, and it's just because that's how they look. These muscles have nuclei kind of like everywhere. If you look at the picture labeled, you can see where the nuclei are, the darker pink little blobs that make up the muscle. And that's important for just how the skeletal muscle just functions and how it's made up of. Now, the skeletal muscle is voluntary. That means you direct its movements. Obviously, there are some muscles like in your eyes that you use to blink that you may not consciously be doing. Like, you're not going to tell yourself, okay, got to blink. Oops, didn't blink for the past 30 seconds, got to blink. But for the most part, your skeletal muscles are voluntary. And so if you ever hear of a voluntary muscle, it probably refers to your skeletal muscle. This is just because they're directed by conscious nerve activity. So now let's get into the organization of muscles. So if you look at this diagram, there's also one in your book that I would suggest opening to. There's something called a muscle fiber. Now, your muscle fiber kind of looks like a piece of thread, and the amount of muscle fiber that each person has is actually genetically determined, and it won't change unless you have some kind of injury that might take away from your body. But basically, when you have muscle fiber in your skeletal muscle, these are fibers that are going to grow in length as you get older and as you grow up. And as as they grow in length, they will also increase in strength and diameter based on exercises and strength training and things like that. But basically, your muscle fiber, as you can tell in the picture, is going to be an individual muscle cell. So that's pretty much your muscles are made up of all these muscle fibers, which are these individual muscle cells. They do have a ton of nuclei. You can kind of tell here. These little blobs are your nuclei that make up the muscle fiber. And then obviously, like I said, they do run in the entire length of your muscle. So depending on how big your muscle is, they can either be shorter or longer. You have different lengths of muscle fibers that go through your body depending on the location. Moving on, there's something called a sacrolemma. Now, sacrolemma is basically means that it's a cell membrane, kind of like your plasma membrane that surrounds your cell. But sacrolemma is pretty much the cell membrane of your muscle fiber. So they are going to wrap around your muscle fiber. And this is an important component just for extra protection as well as for structural support. Then you have something called your endomyosum. You can see that here in the square. But basically your endomyosum is going to cover your sacrolema. It is made up of a type of connective tissue. And it is to serve as a protective coating as well. So your muscle has a lot of protective coating, which is important because, you know, any activity that you do really can cause muscle damage or muscle tear. And so you want these extra protections, you want these extra layers to cover up your muscles in order to give them the best support and protection. After your endomysium, you have something called your fascicle, which is just a group of muscle fibers. So here is your fascicle, also in this little rectangle, and you can see that it's wrapped around a bunch of muscle fibers. That's just a way of grouping, and it allows, again, them to be contained, structurally supported as well. Then you have your paramecium, which is going to, it's kind of like the white border that you see around your fascicles. And they are going to also support, they're kind of like, they're referred to as a bundle of muscle fibers. And when they're put together like that, they are very strong. They're made up of fibrous membrane, and they are there to just contain the fascicles in a stable unit. So they play a very important role in that as well. Now, there's something called the epimyosum, which is a connective tissue that's pretty tough, and this is going to surround all of the fascicles, okay? So you can see that right here. It's kind of like outside of the white boundaries, you have this like kind of off-white boundary that's going around the entire fascicles system and around all of the parameciums. This is really going to be enclosed around your tendons, and this is going to be made up of tissues, which are going to give the entire muscle a very good structural unit and hold them in place. The epimyosum actually connects at both ends of the muscle, whether there's a tendon, which is, you know, strong connective tissue that you can see down here, or if it's flatter tissue, it can also, also known as the aponeurosis, which is, like I said, flat tissue. They can either surround them as well. Both the tendon and the aponeurosis actually do connect the muscles to either bone, cartilage, another type of connective tissue. So they're really there to bridge the gap that you have between muscle and what they're connecting to. So this is kind of your skeletal muscle. Remember, your skeletal muscle has to do with how it's connected to your skeletal system. Now we're getting into smooth muscle. Smooth muscle, you can kind of tell, look a lot different than skeletal muscle. Remember, this is how skeletal muscle looks like. It's longer, they're more striated, more parallel looking. Smooth muscle kind of look like funkier cells. Smooth muscles are a lot smaller than skeletal muscles. They have a shape to them, and they refer this shape as a spindle shape. They don't have any striations, hence the smooth part. And they're involuntary. That means you do not actually control them. And that's a good thing, because they're actually controlled by something called the ANS, also known as the autonomic nervous system. So this is like your digestive system, things that like your stomach, your intestines. You're not controlling the digestion of your food. It automatically does it, and that's because it's made up of your smooth muscles. Your ANS, or your autonomic nervous system, is actually controlled by a part in your brain called the hypothalamus. Your hypothalamus is also in charge of controlling your heart rate, your digestion, your urination, things like that. Okay, so your smooth muscle is also known as your visceral muscle. And these are the ones that make up the wall of your internal organs. So they are found inside of your stomach, your intestines, your urinary, your bladder, your respiratory passages, all these things that are automatically, unconsciously doing the work that needs to be done without you actually having to think about it. There are two smooth muscle layers. One runs lengthwise and then one goes around the organs. So obviously the lengthwise one is your longitudinal layer, which is going to be on the outside, and then your circular layer, which is going to be on the inside. There's something called peristalsis, which is basically when you have contraction between the of the two layers of the longitudinal layer and the circular layer of the muscle cell. So you can see here you have the longitudinal layer, which is covering the outside of the intestine, and then you have the circular layer, which is covering the inside. So peristalsis, you're going to have to excuse me as I mispronounce this a bunch of times, is basically when, like what I said, because of these contractions that are occurring between the longitudinal and circular layer of the smooth muscle, you are going to have digestion occurring in your intestines. This is what really moves the food along and allows you know, your food, once you've eaten it, to go through your entire intestines and your digestive tract. And peristalsis can actually occur for a long period of time, because it's not like you digest within a couple of seconds or a couple minutes. You can be digesting for hours depending on what you eat. And so the strength that this the smooth muscle has as it does this is actually going to last longer than you would if you were using your skeletal muscle, which you could probably wear out rather quickly. The next type of muscle is your cardiac muscle. So remember, cardiac muscle, you probably guessed where it is. Obviously, it's in the heart. These have branched fibers that you can kind of see happening in this image right here. And they do have a lot of striations. These are called cross-striated. These are also involuntary muscles because, again, it's controlled by your ANS, or your autonomic nervous system, because you don't tell your heart to beat. Your heart automatically does it. Thank God for that. And they do have something called intercalated discs. So you can kind of see that there's little like parts of your muscle that look like they're kind of merged together at specific areas. Those are your intercalated discs. You can probably see it here. And basically these are just the way that your fibers in your cardiac muscle connect together. Because of these intercalated discs that occur throughout your cardiac muscle, you can have a contraction happening in your heart cell or your heart muscle itself that causes all of the other muscles around it to also contract, and therefore you're having a heartbeat simultaneously. They're all beating together. And this just allows for unison or unity of your heartbeat, so that, you know, the whole muscle is beating at once and not parts of it. The next slide is going to just show you right here. If you have to pause at any time to copy down notes, please make sure you do so. But this is just a really well done table that you can find in your textbook that kind of breaks down your skeletal, smooth, and cardiac muscle between what they look like, what type of nucleus they have, what kind of control, is it voluntary or involuntary, and then where they're located. So we kind of talked about all of this, so make sure you know these as you go through studying, and then this will help you on your quiz and your test as well. All right, let's get into muscle function. So now that we talked about what a muscle looks like, what are their functions having to do with? So one is that all muscles have 4 behavioral characteristics. One is called, the first behavioral characteristic is the irritability they have, which is basically their ability to respond to a stimulus, okay? Their extensibility, which means that they can stretch. Obviously, if they go beyond their stretching point, it can cause damage, but you do have muscles that are able to stretch, which is great. So for example, your hamstrings, as you stretch your hamstrings over time, the muscles will actually start to get longer and lengthen, and you will increase your range of motion, especially at your hip. And you are able to touch your toes more easily. For me, example, I had a lot of issues with my hamstrings. I wasn't able to touch my toes. I still actually can't, but it was causing a lot of pain on my knees. So when I got it checked out, the doctor was like, wow, your hamstrings are so tight. And so they wanted me to go to physical therapy to kind of stretch it out. It will take some time for that to happen, but the more stretching you do, obviously in increments, not at once, it will help to extend that ability. Thirdly, you have elasticity, which is the ability for your muscle after being stretched to come back to its normal length as well. And then contractibility is when you can contract or shorten your muscles. Most muscles have a tendon attached to the bone on each end. So when muscles contract, they actually pull the bone at the attachment site. And this pulling force is called the tensile force or tension that we talked about earlier, I think in chapter 1. And that's what happens when you have the tensile force. So it's literally you're pulling an object in opposite directions to make it longer or thinner. But make sure that you're not doing it extremely, because then you can actually damage your muscles. When you have tension occurring, what you have is that you can either shorten your muscles. So a lot of times when you have tension, it doesn't mean that your muscles are only going to shorten, but they can shorten. They can either remain in the same length, or they can get longer. So when you have tension in your muscles, these are the three things that can happen. Doesn't necessarily mean they're tight, but it can also mean that they're longer or they are the same length. So it really depends on what you are referring to when you talk about tension occurring. There is something called concentric contraction. This is when you have a shortening of muscles. So when you apply tension to, for example, your biceps, they start to shorten, which means they are contracting. And this is a form of concentric contraction. So you can tell in this picture that you have this person lifting their weight, their biceps, which is in their anterior part of their arm, when you're standing in your anatomical position, is shortening. There are two terms that go with this. You have your agonist and your antagonist, kind of like in English, right? So your agonist is going to be your main mover. So this is the movement that the muscle that you're really focusing on to move. And then you have your antagonist, which is going to go in the opposite direction of your agonist. And so this can either be and while your agonist is, being flexed, and the prime movement that you're focusing on, your antagonist is going to be relaxing, and it's not going to be as tense. Or it can also tense up with the agonist if you're working that muscle as well, or moving the opposite of your agonist. Then you have your eccentric contraction. This is like if you are holding a weight and your biceps cannot hold it for a long time, you would have to lower it a little and your biceps would lengthen. So this is pretty much when your agonist is your bicep, you are lengthening it. This causes your triceps, which would be your antagonist, to relax a little bit more. And then you have isometric contraction, which is when you have no movement of your muscle. This helps with posture and to stabilize your joints. So there's no changing occurring in your agonist or your antagonist. This is like when you flex your muscles and you develop a tension in your triceps and your biceps, but there's no actual movement happening. So this is like when you're holding a weight and you're just holding it. You're not doing any kind of motion. Production of heat is also something important. When you exercise, obviously you get really hot. This is a form of production of heat. You also are producing a constant heat supply when you're not exercising. Even when you are just chilling on your couch, being a couch potato, you are also producing heat because that's just a way for your body to keep homeostasis in order for your body temperature to be at normal. And this is happening because of something called ATP, adenosine triphosphate, which is an energy molecule your body makes. And is used a ton in your muscle, especially when it is being used. So your muscles actually have a ton of mitochondria. If you remember, your mitochondria is the powerhouse of your cell. And your mitochondria is what makes these ATPs or recycles the ATPs as they're being used. And so because your muscle requires so much energy all the time when it's moving, you have a ton of mitochondria in your muscle cells in order for ATP to function. Okay, so let's do a little bit of a review. True or false? Smooth muscle is voluntary. What do you guys think? If you said false, you are absolutely correct. Next, cardiac muscle has branching fibers. What do you guys think? If you said true, you are absolutely correct. Smooth muscle is multinucleate. Does smooth muscles have multiple nucleus in each of the muscle cell? No, it does not, so this is false. Paramecium wraps fascicles to make a muscle. This is false. It's the epimecium that does that. Endomecium surrounds the muscle fibers. This is also false. Endomecium surrounds the sarcolemma. All right, so let's label and match these words. If you have some kind of respond to an environment, this is known as irritability. If you have an opposition to the movement, say against an agonist, this would be your antagonist. If you are stretching, this is called extensibility or extending. Shorten is contractibility, you're contracting, and then anything that is doing the movement or causing the movement is your agonist. All right, that's it for 5.1. Please make sure that you review all of this material so that you will be ready for your quiz and your chapter test at the end.